Okay, I want to briefly talk about the arctan function. So let's write this down. And I'm going to say y equals the arctangent. All right, you should visually understand arctangent. The function looks like this. All right, so the domain of this over here is actually all real numbers. So the domain, x, could be any real number. And what's the range of this thing over here? I'll just say y is a range. What's the range going to be? Well, it's going to be from minus pi over 2. It's not going to touch it. Up to pi over 2. So looking at it, it's a double angle formula, so I know the cosine, regardless of the angle given, it can handle it, all right? So I know the domain of this thing is all real numbers, all right? So what I want to do is look at the problem, and the first thing I notice is the double angle formula. So what I want to do is write that down. So I'm going to write down, with the understanding that y equals the arctangent. So I'm going to write down cosine of 2y. What's it going to equal to? And there's a variety of ways of writing it down. I'm just going to write down 2 cosine squared minus 1. I got that part covered. All right, then what are you going to do over here? Looking at it, you could go to the triangle, all right? And the reason for the triangle, let me just point out what I mean by a triangle, that I'm looking at a triangle. Now, before I discuss it, I want to point out, before you do that, is you're noticing what the y is between those two numbers over there. And what I know about the cosine of that, well, the cosine curve between those, and again, we're just talking about this over here, the cosine curve between those two values is going to be always positive. All right, so I'm pretty clear about that. All right, that's an important thing, by the way. So what I'm going to do is, I'm just going to look at a triangle right now. And what do I know about the triangle? I know that the tangent, let's write this down now, that the tangent of y, and again, y is between minus pi over 2 and pi over 2, is going to be equal to x. So I'll put y here. And what do I get? I get x over 1. And what's this going to be? Pythagorean theorem, it's going to be x squared plus 1. So I think I know the cosine of y just looking at that picture. The cosine of y would be equal to, let's take a look at that. That's going to be, cosine is going to be 1 over the square root of x squared plus 1. All right? So I think I can write that down now. So what do I get over here? 2. Well, when I square the cosine of y, what do I get? And again, I'm looking at that over there. I get 1 over x squared plus 1, and then minus 1. All right, look at the triangles. Most of your teachers would do it. So common denominator would be x squared plus 1. And what do you get over there? You get 2 minus x squared plus 1. All right, let me take a moment to look at that, make sure I did that right. Yeah, it looks pretty good. So what do you do now? Well, 2 minus 1 is 1. You get 1 minus x squared over x squared plus 1. Go look at the key now, and I'm hoping to see that. And really, when you take a multiple exam, you're hoping to see that your work leads to an answer that's listed over here. Do I see that? It's right over here. I do want to go through the key with you, though. And someone says, why do you do that? I want to make sure you know that you should read these things and try to understand what's being presented to you. We will do the graphing of it, all right? The other thing I want to point out is you probably should graph both this and what I said it's equivalent to. And I said it's equivalent to on that interval from minus infinity to infinity, by the way, all right? Now, they're not asking for the restrictions, but I want to say, you know what? A lot of times you're not really sure about that. Like you make a mistake. A lot of times I say something that's not true. It's nice to have verification, whether it's from another human saying I'm right, from an answer key that's saying I'm right, or me looking at visually and showing it's right by looking at it visually. But I do want to look at it visually. We'll get to that later. What I want to do is I want to go through the work over here. And to do that, what I want to do is step by step. So what I do over here, I'm using the double angle formula. I got that written down. The next thing I did was what I did before is that y equals arctangent of x, just to make it a little bit easier. And if that's true, y equals x. Again, I want to point out over here, the y can be any number between minus pi over 2 and pi over 2. And the x is going to be any real number. So the x can be between minus infinity and infinity. All right? And what I do now, I square both sides. Relatively simple, by the way. I mean, if you square both sides, relatively simple. Then what do you get over here? I add 1 to both sides. Someone says, why are you doing that? I'm looking to get something that's related to the cosine. So by adding 1 to both sides, I see a Pythagorean identity. So the 1 plus tangent squared is secant squared. You notice I'm avoiding, the triangle at this point. So what do I do over here? If the secant squared of y is equal to 1 over x squared, the cosine squared of y would be equal to this over here. All right? Now someone says, what are you doing over here? Well, it's the cosine squared of y. What was y? It's written over here. It's this. That equals this. What am I going to do now? Plug it in. So 2 times that. I write that down. You notice we got this also from the right triangle, by the way. And simplify it, just like we did before. Are we getting the same thing? Yes, without the use of a triangle. Most teachers use triangles to do the problem, by the way. Thank you.